So this video, I decided to do something fun, and show you a problem that had me just lying awake the other night. I could not go to bed until I solved this problem because that's the kind of nerd I am. But anyway, it's a problem. How do you solve a log problem when the logs are different bases? Because I'm a math teacher and we don't teach this in school. And so I thought, well, there's gonna be a way to do it. So I just decided to use the skills that I have and see if I could, and I did. So now I'm gonna show you how, just in case you ever find yourself in this position. So here's the problem, and you can see that we have logs with two different bases and we wanna solve for x. And so I thought, well, what if we use the change of base formula? And presuming you're watching this video, you probably already know what the change of base formula is, but let me just remind you. It's if you have a log of a base x, you can rewrite that in terms of common logs. You would do the common log of x over the common log of b, and that's one way to get the bases to be common bases, which is the 10. So that's what we're gonna do there. Okay, so let me just, so we don't get it confused with what we're actually doing. So I'm just gonna convert these into being the common bases. And just for those of you who have a hard time with fractions, I'm going to put the 5 over 1 so you can see that we're dealing with all fractions. And then since I'm adding these two logs together, I'm going to go ahead and get a common denominator. The way I like to get a common denominator is just multiply the numerator of the first fraction with the denominator of the second, and the numerator of the second fraction with the denominator of the first. And then all that'll go over a common denominator where you just multiply the two denominators together. There. And then from there, if I was going to solve for x, I'd probably want to cross multiply. So cross multiply is where we're going to multiply all of this numerator by that denominator. And then we're going to multiply this numerator by this denominator. That's called cross multiplying. So then it would say that. Now at this point, I'm totally overwriting the word log. It's just taking up a lot of space. So I'm about to head to my handy dandy calculator and just turn those logs into decimals and round to the thousandths. That should be enough to get mostly the precision that I'd like to have. So I put the log 2 and the log 3 in my calculator, as well as this expression, and I got decimals because that's going to be so much easier to deal with than just keep writing the word log over and over again. Now I'd like to ultimately combine these logs together, and so I'm going to use some properties to be able to do that. First property I want to use is the power property, and that says that when you're multiplying something into a log, you can actually make it be the exponent to these pieces here. Okay, so that's going to give me log 4x all to the 0.301 plus log x to the 0.477. And here, that 0.301 is the exponent to both of these elements. So we're going to raise 4 to the 0.301. And that is going to give me 1.518. I did that in my calculator earlier. So now I got log 1.518 x to the 0.301 plus et cetera, et cetera. Oops. Okay. And then I'm going to use the product property to combine these two logs into a single log. The product property says that I can combine logs that are being added together into a single log by multiplying whatever's in this spot here. So that's going to give me 1.518. And then when I'm multiplying variables together, I'm really adding their exponents. So I'm going to add the 0.301 to the 0.477, 0.778. So that's going to give me x 0.778. Like that. Now I've got it to where it's ready to go into exponential form. And so log is bay. So now I'm going to rewrite this in exponential form. Now since I don't see a base, obviously it's a common log. It's got a base of 10. So my base is 10. My exponent is 0.718. And this whole bit is what goes over here in the answer position. Now I'm going to evaluate what is 10 to the 0.718. 5.224. 5.224. We're nearing the home stretch, kids. We're nearly there. Hang tight. We're almost there. And now I just need to finish solving the equation for x. So if I wanted to solve that for x, first I'd want to get rid of the 1.518, so I would divide it off. Put that in my calculator, which I already did earlier. It makes 3.441. And that equals x to the 0.778. And then to undo any kind of exponent, you take the root. So we're going to take the 0.778 root of all this, and thank God for my handy dandy TI-84 Plus calculator in color. And I can just, I have a little function that'll allow me to take whatever kind of root I want to take. So 4.896. So 4.896 equals x. At this point, I'm going to go plug that 4.896 back into the original equation to see if it works, and it will, but I'll prove it to you. Here we go. So our answer is 4.896, and we're about to figure out if we got the right answer. So we're going to take that answer, and we are going to plug it back in for the x's in our original problem, and if they come out to be 5, we'll have done the problem, that's a thumbs up, we'll have done the problem just right. So I did put that in my calculator, and I'm about to hit enter, and if I get 5 or anything close to 5, I'll have known that I did it right. Woo! 4.99999, which is very close to 5. The reason we didn't get exactly 5, of course, is because of the rounding. But we did it. We did it. Thanks for hanging with me, kids.
Hey guys, don't forget to like, subscribe, and check out my website at oliviashirleytutoring.weebly.com, where you can schedule one-on-one tutoring and contact me.